Okay. So the first thing I want to talk about is a reference angle. And this is something that I think you know what it is, and we've kind of danced around what it is. But let's go ahead and officially define it. So I want you to take 30 seconds, turn to your neighbor, and discuss whether you think you know what a reference angle is, and if you do, well, whether you do or not, talk about what you think it is. 1, 2, 3, go. Your definition is so vague. Okay, who feels confident in their answer? Okay, then pod 6, tell me what you discussed. I don't care whether it's right or wrong. Yeah, so I'm looking at you.
An angle of a reference.
Okay, what are we referencing back to? What are we referencing back to? Or what did you talk about? Okay, so we're referencing an angle that is, I'm going to change it to acute. Okay, so a reference angle is acute. Okay. Okay. It's the acute angle formed by the terminal side and the horizontal axis. So for right now, I'm going to call our reference angle theta prime because it has a relationship with our angle theta. Okay. So it's the acute angle that basically takes us back to the horizontal axis or back to the x-axis. Why are acute angles important when we talk about trigonometry?
Because isn't it with any math that we can do, it will be a lot simpler in the acute.
Yes, you're on the right track. Yeah, it makes things simpler because we can draw what with an acute angle? We can draw a triangle. We can draw a right triangle with an acute angle, okay? And so if we have a reference angle, we can draw a reference triangle and help us solve functions in different trig functions in different quadrants. Okay, we're really good at drawing triangles in the first quadrant, 30 degrees, 50 degrees, whatever. But now we can have a reference angle in different quadrants and evaluate trig functions there. Okay. Now I told you today we were going to focus on the unit circle side of things. Okay. So we're going to practice finding a couple reference angles, but with our special angles. Okay. So the first reference angle I want to find is 315 degrees. Okay, so I'm going to draw a picture. We're going to talk about it. And I know some of you could probably tell me what the reference angle is without drawing a picture, but I think for tomorrow when we get to angles that aren't our special unit circle angles, it'll help if we draw a picture here. So 315 degrees, what quadrant is that in? So here is 315 degrees. Remember, our reference angle is always back to the horizontal axis. So this right here is our reference angle. No matter which way we are rotating, our reference angle is always positive. What's our reference angle, Kyler?
45 degrees.
And how did you get that?
360 minus 315.
Okay. Since we're going to the x-axis, 360 is a value that would be useful to us. Okay. Since 315 degrees has a reference angle of 45 degrees, its coordinate on the unit circle is similar with just different negative and positive values, right? 7 pi over 6. What quadrant is that in? 3. Okay. Our reference angle is always back to the horizontal axis. So this right here is our reference angle. How do we find it? I know some of you already know what it is without doing the math, but let's talk through step by step. So tomorrow, when we don't have these special values, we can still do it. How do we find the reference angle in this case? Okay, so we want what's left over right here. So we can take 7 pi over 6 and subtract pi. And what do we get? Pi over 6. Pi over 6 is the reference angle, which is why 7 pi over 6 has a similar coordinate, except our positive and negative values are changed. Okay. Tomorrow we will work more with reference angles, okay? But it's not as major of a concern today, okay? But I just wanted to intro it a little bit. So tomorrow it'll be a little bit more smooth. Okay, so what we're going to do now is we're going to talk about evaluating, much like you did on your worksheet, but we're going to talk about when maybe we have negative rotations or rotations that are more than 2 pi. Okay, and then we're going to talk about going backwards a little bit. What if I give you the ratio? Can you tell me what the angle is? Okay. So let's talk about these first. Okay, we'll start off simple. Cosine of 4 pi over 3. Nate, can you tell me what that is? 1/2? Do you agree?
Negative.
Why is it negative?
Because it's in the third quadrant.
It's in the third quadrant, so we better put a negative with it. Now do you agree? Okay, excellent. This is the kind of problem that I know that you saw in your homework the other day, but some of us were kind of uncomfortable with it, so I want to talk about it again. The tangent of 210 degrees, negative 210 degrees, okay? You may want to think of its coterminal angle. Where is negative 210 degrees? In the second quadrant. Okay, negative 210 degrees would be the same as, what did you say, Kyler?
150 degrees.
Positive 150 degrees. Okay, so if you want to rewrite this to the tangent of 150 degrees, you can. All right. Now, what is the tangent of 150 degrees? Let's talk about what the coordinate is. Layton, what's our coordinate? Negative radical 3 over 2, 1/2. So if we want to find the tangent, we take y divided by x. There's our y divided by x. We're left with negative 1 over radical 3, which is negative radical 3 over 3. I'm hoping by the end of this week that when I talk, that when you see the tangent of any 30-degree angle, you won't have to do the division. You'll remember that it's radical 3 over 3. Okay? But if you have to do the y over x, that's not a problem. But I think eventually you're going to get to the point where you're going to recognize these values and not have to remember, or not have to take the y divided by x. All right, cosecant of 11 pi over 4. Cosecant of 11 pi over 4. Okay, 11 pi over 4, that's more than 2 pi, isn't it? How much more than 2 pi? Okay. So you could say that a coterminal angle for 11 pi over 4 is 3 pi over 4. Do you agree? Okay. So you could just change this to the cosecant of 3 pi over 4 because it's really the same, because we're at the same place on the coordinate plane. Okay? And what is the cosecant of 3 pi over 4? I mean, radical 2. We have to take the reciprocal of radical 2 over 2. Okay. So here I'll walk through that in case you need a visual. Okay. We take the reciprocal of sine. When we rationalize it, we get radical 2. So basically, if you have a negative angle or an angle that is rotated more than one rotation, think about the coterminal angle, and you can change the problem from there. Okay, so as promised, we're going to work backwards now. Okay, so this is what you're going to get. You're going to get something that looks like this. Cosine of theta equals 1/2. And what I want you to do is I want you to tell me the angle between 0 and 360 degrees, or 0 and 2 pi, that satisfies this equation. Okay, so basically we need to ask ourselves, where is the cosine 1/2? First of all, how many times is the cosine 1/2 on one rotation of the unit circle? Two different places. And what quadrants does that happen in?
1 and 4.
1 and 4. Okay. If you need this reminder, this is where sine, cosine, and tangent are positive. All just sine, just tangent, just cosine. These are where they're positive. Okay. So we are positive in the first and the fourth quadrant. So in the first quadrant, where is cosine 1/2? Joe, can you tell me? 60 degrees. And if cosine is positive 1/2 at 60 degrees, okay, Grant told us that we're also positive 1/2 in the fourth quadrant. Where would that have to be? Tyler?
300.
300. Let's think about our radians. Kayla, what would that be in radians? Very good. So we just have to think backward. Which angles give us this ratio? Yes, all the possibilities. Sometimes there's going to be two. Other times it's possible that there's just one, and we'll look at that. Okay? Here I have the cosecant is radical 2. The cosecant is radical 2. So first of all, the cosecant is the reciprocal of sine. Okay? How many times on our unit circle is the cosecant radical 2? 2. Which quadrants? Okay, 1 and 2. All right. So in the first quadrant, where is cosecant radical 2? Sarah, can you tell us? You don't know? Radical 2. Who said that? What did you say, Layton? Eric said it?
He said 45.
45 degrees. Let's talk about why it's at 45 degrees. The sine at 45 degrees is radical 2 over 2. Therefore, the secant, the reciprocal, is radical 2. You need to start recognizing these numbers. Okay? And if the first quadrant angle is 45 degrees, then what is our second quadrant angle? Josie? $135. Okay. And then in radians, good. Next one. The tangent of theta equals undefined. Anytime we have an undefined value, it means we're dividing by what number? 0. Okay? Tangent we find by taking y divided by x. So if undefined means we are dividing by 0, we need to focus on where x is 0. Very good. And where does that happen? Courtney. Okay, let's think about that again. Kayla said we need to focus on where x is 0.
Oh, 270.
Very good. Is there another place? And 90. Okay. At 90 degrees, our coordinate is 0, 1. At 270 degrees, our coordinate is 0, -1. So when we take y divided by x, we get undefined. And then in radians, we have pi over 2 and 3 pi over 2. Sine of theta equals 0. Okay. The sine comes from which coordinate? The y coordinate. So this is basically asking, where is the y coordinate? 0. Maddie, where does that happen? 0 and 180. Well, let's go back to our instructions. It said between 0 and 360, but there wasn't equality. So I'm fine with just 0 and 180. Okay? Now, on a test or a quiz situation, if you put 360, I'm not going to be upset. Okay, so this is what we're going to do. I could go through example after example after example, and you can sit here and whatever's in mind. I'm not quite ready to send you into your homework because I think we need to practice a little bit more. So what I'm going to have you do is I want you to get out your unit circles. Get out the unit circles that we created on Thursday, so your big unit circles.